thank God you found this video before your UTME. This is equilibrium in chemistry. In JAMB, they will ask you questions based on temperature change, concentration or effect on concentration, pressure, and catalyst. And these questions used to seem like they are coming down from above. But in this video, I'm going to teach you, and it's going to be very easy for you. All you need to do for me, subscribe so you're going to be seeing my next video. And if you have any topic that is bothering you, let me know in the comment section. What do you mean by equilibrium? In your mind, you're saying that it is something that is balanced. Yes, equilibrium means what? Balancing. In physics, we talk about something like a meter rule and a pivot. There is something here, there is something here. If this mass is equal to this mass, this meter rule will not shake, depending on if this is the same. Or if it's not the same, maybe someone here will increase the mass of here to meet that particular length. Hence, the system here is in what? Equilibrium. Now, what you have to know, if this is in equilibrium, it does not just last in equilibrium. No. In that particular equilibrium, there are some force between these masses that are dragging each other. There are some force working in this meter room. And because those forces are equal, they cannot what? Conquer each other. But even though they seems not to be what? Working again, they are still dragging each other in that same equilibrium. All right. Now, here is talking about physics. What of in chemistry? We're not talking about meter, we're talking about chemical equilibrium. What do we mean by chemical equilibrium? Now, let's say that this here is the earth, that is the soil, and something here is growing, which we call the tree. Now, this soil contains what we call nitrogen. This nitrogen will be absorbed by this plant to form protein. And what happens? As nitrogen is converted to form protein, once this plant dies, it decays. Once this plant dies, it decays. And once it decays, this protein will also be converted back again to nitrogen, what it was before. So this process, as you can see, that nitrogen converting to protein will still again convert back to what? Nitrogen. It means that they are what? In reverse reaction. Hence, I can put the expression as nitrogen is giving me what? Is giving me protein. All right? And if it is giving me protein, at a point in time, this protein is going to give me back what? Nitrogen. This is what I mean by what? Equilibrium. So they are under what? Equilibrium means that the reaction is what? The reaction can give us the product and also give us back the reactant. Are you getting me? Now, we move on further to another example on explaining equilibrium. Equilibrium could also be seen as when you put a boiling pot in water, a water in a pot and you ignite a heat, the water starts boiling. Let's say you cover this pot. Once you cover it, this is the cover here. When this water starts boiling, there is an equilibrium between this water and the vapor. What did I mean? If this water is boiling, you're going to be seeing that there is a vapor that is going to be touching this particular cover pot. And once the vapor is touching below the cover, that vapor will also be converted back to water and drop back in this water that is boiling. And this same boiling water will also be the releasing vapor, and the vapor will also be coming into the water again as water. It will keep on going in that particular what? Process. So this is a what? In equilibrium, because the reactant gives us a product which is vapor, and the vapor could also give us back what? The reactant, which is what? The water. All right. Now, in that what I said, here is a chemical reaction apart from the normal life explained that I just explained here. Now, we are going to talk about temperature. For example, let's digest this reaction here. We say that hydrogen reacts with chlorine to give us hydrogen chloride. And as you can see here, this is what we call heat or energy. This energy is being what? Released in the environment. I'm going to tell you how I know that this energy is released in the environment. Now, temperature change or effect. This reaction here can be exothermic or endothermic. For example, if I put in a reaction on this particular bowl here, and this reaction has to release maybe it is explosive. Once you put a reaction, it start to remove heat in the environment, just like acid or nitrogen. We what? We remove sodium, I mean to say, we release energy in the atmosphere. That is heat. That heat is vibrating. I'm going to put it, maybe the value of that heat, and I'm going to put it a negative sign. This negative sign means that it's what? Releasing energy. But what if that particular reaction is gaining energy from the what? Atmosphere instead of releasing energy? It is called what? Endothermic. Hence, this expression, you're going to see it as positive. So once you see something that is related to temperature on your JAMB, you're going to look at this particular energy liberated. Negative means it is what? Exothermic. Positive means it is what? Endothermic. Now we are now going to be talking about the effect of particular temperature. Now, because this expression is exothermic, if I should increase the temperature, what is going to happen to this reaction? Remember, from hydrogen reacting with chlorine gave us hydrogen chloride in an exothermic reaction. Now, for this hydrogen chloride, because this is a reverse reaction, as you can see over here, for this hydrogen chloride to give us to react back, to give us back this reactant, it is going to be in what? Endothermic reaction. These people come together, fuse, heat, boom. This heat vibrated and they form together to give hydrochloric acid. Now, for this hydrochloric acid to dissociate again and give us back this hydrogen chloride, what is going to happen? They are going to absorb heat and dissociate back to this. That is, the backward reaction is going to be what? Endothermic. Be very, very careful. It's going to be what? Endothermic. Why the word forward reaction is going to be what? Exothermic. It's going to be exothermic. Are you getting me? So the forward reactant is shown from this energy, which means it is what? Exothermic. Hence, the backward reactant will be what? Endothermic. Now, if I increase temperature in this particular reaction, it is going to alter this equilibrium. And according to a law in equilibrium, they will try to adjust themselves in order to regain that equilibrium position. For them to regain that equilibrium position, as I have increased this temperature, this reaction is going to favor what? The backward reaction, which is requiring what? Energy. Remember, increase in temperature in an exothermic reaction is going to favor the what? The endothermic reaction. Where is the endothermic reaction? The backward what? Reaction. So the reaction is going to move to the what? To the left. Are you seeing it? It's going to move to the left when I increase the temperature because it is favoring the endothermic reaction, which is what? Backward reaction. But when I do what? When I reduce the temperature, there will be more what? There will be more temperature liberated. Hence, it will favor the what? The right hand reaction. Sorry. The increase in temperature will favor the left, will make this reaction to move the left hand side, yes, and the decrease in temperature is going to make it to what? Move to the what? Right hand side reaction. So notice it that increase in temperature is going to what? Favor the endothermic reaction. Why decrease in that temperature will favor the exothermic reaction. So let this temperature decrease because this reaction is exothermic from this negative sign that shows that it's exothermic. It means that it is going to what? Move to the what? The right hand side. The reaction will move to the right hand side so that it is going to what? Balance this particular equilibrium. But if the temperature increases, it is going to favor the endothermic. This from here to here is exothermic. Hence, from here back to this place is going to give us what? Endothermic. So that it is going to favor the endothermic and the reaction will be moving what? Backward, which is moving to the what? Left. There's a question like that. You're going to see it at the end of this video. So having noted the effect of temperature, hope it is well understood. We move to concentration. Now, concentration, as you can see, hydrogen plus iodine will give us hydrogen iodide. What do we mean? There is an equal concentration of hydrogen and iodide here, which makes this equation to be balanced. But whereby the concentration is being altered, for example, I am going to add hydrogen I'm going to add hydrogen to this system. Remember, these reactions are not just in a straight line. This reaction is something, maybe they put it in bowel. Inside that bowel, they put hydrogen, they put iodine, and in this bowel, you are having what? Hydrochloric acid, sorry, hydrogen iodide inside that bowel, and also hydrogen and iodine is still inside there. I get it. Now it is not in a straight form. Oh. Are you understanding? Now if I should add hydrogen inside this particular reaction, you're going to see that what? You're going to see that the concentration of what? Of hydrogen is going to increase because I have added what? Hydrogen in this reaction. The concentration of hydrogen will what? Increase. If the concentration of hydrogen increase, this reaction is no longer in equilibrium again. This side is now bigger than what? This side. Because of that, they will try to make themselves to be equal again. And to make themselves to be equal again, iodine is going to react with more of hydrogen that I have put or added to this reaction over here to produce more hydrogen iodide. Are you seeing that I am producing more hydrogen iodide while I having addition of what? Hydrogen. Hence, if I should put hydrogen here, the reaction is going to move what? Move at the right hand side, favor the what? Product side, because more hydrogen peroxide will be what? Will be produced from iodine reacting with that hydrogen I put here. Hope you understanding. Now what if I put in iodide? The same thing will happen. Hydrogen will also react with that iodide and keep giving me what? Hydrogen iodide. Now, assuming I am putting hydrogen iodide inside this particular reaction, what is going to happen? If I put hydrogen iodide inside here, the concentration of hydrogen iodide will be bigger than what these people here are producing. Hence, there is going to be a dissociation of hydrogen iodide when I put in hydrogen iodide inside this water. They are going to dissociate to produce more of hydrogen and what? Iodine. Because they must be in what? Equilibrium. Because of that, this reaction is going to shift to this particular left hand side over here. Hope you're understanding. All right. Now that is it. You can also see that in some question they will give it to acid and base. I'm going to show you a question that shows that. Now pressure. Let's go to what? Pressure. Hope you have understand this. Concentration means that they are adding something. So once something is added, check the consistency of that particular substance that is added in the reaction. If it something here is involved, know that it is going to favor this, it's going to increase this equilibrium side so that it is going to react more to produce here. And if it's producing more here, that means the reaction is shifting to the what? Right hand side. We're going to look at that. Now, pressure. What do we mean by pressure? Pressure. In pressure, effect of pressure on equilibrium. This same reaction here you're seeing is also in what? Is also in equilibrium. Here we have Haber process of producing ammonia where you use nitrogen and react with what? And react with sorry. When you use nitrogen, and react with hydrogen in Haber process, you produce what? Ammonia. Now, if the pressure increases in this reaction, what is going to happen? If you can remember Boyle's law states that For a given volume of gas, it is inversely proportional to the what? Pressure at constant temperature, which means that the volume is increasing when the pressure is decreasing. They are not working hand to hand. The pressure increases, the volume decreases. The volume increases, the pressure decreases. Now, can I apply that? If you look at this reaction, we can form something. We can say that one invisible volume of nitrogen reacts with 3 volume of hydrogen to give us 2 volume of nitrogen. So that from this reactant part here, I am having that 1 nitrogen plus 3 hydrogen, that is 3 volume of hydrogen and 1 volume of nitrogen, that's invisible one, is equals to what? 2 volume of what? Ammonia. Now, if you look at the volume, 1 plus 3 is 4 equals what? 2. Now, this reactant part have a 4 volume, while this product part has a 2 volume. Now, what will happen if I should increase this pressure? If I should increase this pressure, remember that increase in pressure makes the volume to do what? Go down. So that increase in pressure is going to favor the side that have the smallest volume, which is this side having 2 as the volume of total product, whereby there are 4 products in the reactant side. So if I should increase this pressure in this reaction is going to move to the what? To the right hand side in order to balance and maintain this equilibrium position here. Hope you understand it. So that is what is happening. Now, what if I decrease this pressure over here? If I decrease this pressure, what is going to happen is that this, because a decrease in pressure leads to what? Increase in what? In volume. Hence, this equilibrium, this reaction is going to move to the side that have the highest what? Volume, which is what? 3 plus 4 is 3 plus 1 is 4, while here is what? 2. So that is what we are talking about. So once this is what? Increase, because I have 3 plus 1 volume here, it give me 4 volume, and this one is here 2 volume. An increase in pressure makes the reaction to move to the side that have the smallest volume, which is this side, while a decrease in pressure makes the reaction to move to the side that have the greatest volume, which is what? This side having what? 4, according to what? Boyle's law application. Now, in that case, we can also identify what is going to happen to pressure if we increase it or decrease it in this other reaction. Now, if you look very well, in this particular reaction here, are you getting me? There is 1 volume of hydrogen reacting with 1 volume of chlorine to give us 2 volume of what? Hydrogen chloride. Now, as you can see, there are 2 volume on the reactant part. I'm working with what? Pressure. I want to increase pressure here, so I will know what will happen. I'm working with pressure. So here I have 2 volume in the reactant side, I have 2 volume in the product side. But remember here, there are no equal volume. Hence, that is why the pressure can be affected. Now, in the case whereby there is an equal volume, there is a what? Equal volume in the reactant and the product side, pressure has no effect. Pressure is not going to affect this particular reaction over here because the volume at the reactant side is equal to volume at the product side, which is what? 2 and 2. Whereby reaction pressure is going to affect here because the volume here is 4, while the volume here is what? Is 2. An increase in volume is going to move to the what? So an increase in pressure, the reaction will move to the side that have the what? Smallest volume, which is what? 2. Why an decrease in pressure will make the reaction to move to the side that have the what? Small highest volume, which is what? 4. Hope you understand it. Now let's look at also the effect of pressure in this particular reaction. Are you getting me? Here I have what? 1 plus 1 is 2. Why this one is what? 2. So also in this reaction, pressure has no what? Effect. Now let's go to catalyst reaction. We are already ending the video so that we can answer a question. What do we mean by catalyst reaction? Hope you can recall all of these negative Change in this means what? Exothermic. While positive means what? Endothermic. And if it's exothermic, the backward reaction is going to be what? Endothermic. All right. Now we enter into catalyst reaction. What do we mean by catalyst reaction? Now this is a now let me say I want to use this particular reaction here. So this reaction gave us ammonium, sorry, gave us two ammonia. Now, if I want to use this reaction is in equilibrium and look at how it happens. From here, it reacts in this form and gave us products. This from here to this place is this nitrogen and hydrogen are still reacting. So they are still reacting, they form products and become in what? In straight form. Are you getting me? Now, this reaction is without catalyst. What does catalyst do? Catalyst increases the rate of reaction. For example, if I want a banana to ripe fast, I'm going to put something in it. It's going to what? Ripe faster. If I want maybe cassava, something like that, maybe soup not to spoil, I'm going to put a charcoal. That charcoal is going to what? Decrease the rate of what? Reaction. So catalyst can increase or decrease what? Rate of what? Reaction. But now let's say that the catalyst is increasing the rate of this reaction. What is going to happen? This reaction, if you can number this is 10, 20, 30, 40, 50, and 60. All right. Now, this is what? Progression. Progression of the reaction. Now, what you're going to do here is, since this reaction without catalyst go from here and form a product here, if I should include a catalyst here, remember that the reaction was still oncoming and started reacting from here. When we put a catalyst, you're going to see that the reaction is going to start faster. As it starts faster, it is also going to not take long to form a what? A product. That is what we have here. This is a what? Catalyst profile. Whereas one is a what? Non-catalyst profile. That's what we mean by catalyst affecting the what? Equilibrium. So catalyst here is going to make this thing to react faster, cause the rate to produce more of what? This particular what? Sodium ammonia. Sorry, ammonia I mean to say. So now we're going to look at questions based on JAMB UTME. So this question is from UTME and my friend provided it for me, so I should help him. Now look at it says, when the system A plus B that gave us C plus D, that's the product that A and B produce, is at equilibrium. When this is at equilibrium, that is, there is a what? Going and coming back reaction and product to reactant. Are you getting me? Neither the A says neither the forward nor the reverse reaction has stopped. B says both the forward and the reverse reaction has stopped. This one is saying that if they're in equilibrium, the reaction that this is producing this and that this is producing this has stopped when they're in equilibrium. Whereby the B says both the forward and the reverse reaction have, okay, it's B that said that both the process that this one produces this one and this one produces this one has stopped. Why A say that neither the forward nor the reverse reaction has stopped. Why B say that when they're in equilibrium, they are still working. This one is still working to produce this one, and these two are still working to what? Produce what? This one. The C says the sum of the concentration of A and B must equal the sum of the concentration of C and D. The sum of the concentration of A and B must equal the sum of the concentration of what? C and D. It is not true. All right. Now, usually to form an equilibrium, the sum of the concentration of this side somehow will be greater than what? This particular side. Are you getting me? Now we move to D. It says the forward reaction has stopped. The forward reaction has stopped when this is in equilibrium. So the forward reaction means this producing this is no longer happening for them to be in equilibrium. The correct answer here is option A. When something is in equilibrium, like I made mention using a meter rule from what we see in physics at equilibrium, if they are in equilibrium, the ruler has balance, it does not mean that there is no reaction going on. These two masses are still dragging each other, and because their strength is equal, they cannot weigh the other person down, but there are still what? Forces acting. So there is still reaction going on here. Are you getting me? So now let's see the next question. In the next question, we have in the reaction, two hydrogen iodide is going to react to give us H, which is hydrogen and iodine, and they're in equilibrium. Now, the energy involved here is 10 kilojoule. And this energy, as you can see, there is no negative. Once there is positive energy, means that this reaction from here to here is endothermic. What did I mean? This hydrogen iodide absorbs heat. That heat that is absorbed make it to dissociate to give us what? This particular what? Product. Now, if here is endothermic, that is gain of energy, from this side back again, this back arrow here, this forward one is what? Endothermic. This back one is going to be what? Exothermic. I get in. Now, the concentration of iodine in the equilibrium can be increased by A, rising the pressure. When we talk about pressure, we look at the volume of both the what? Reactant and the what? Product. This reactant has two volume. Here, hydrogen has invisible one, iodine has invisible one. Two also here. One plus one is two plus this there is two here and two here. Once the volume is balanced in both reactant and product side, pressure has no effect, both increase and decrease. Here, rising the temperature. Can we rise the temperature? Yes. If we rise the temperature, remember that I told you that rising the temperature means that that substance is going to be absorbing that temperature and it is going to favor the side that is what? Endothermic reaction. Why decrease in the temperature means that there will not be any temperature, hence the temperature inside that system is going to be liberated, and the decrease in the temperature will favor the side that is what? Exothermic. Now, because from here to here is endothermic, increasing absorbs energy, and increase in the temperature is going to make this reaction to keep producing more iodine and hydrogen. So more iodine is going to what? Be produced. I getting at a what? Increase in what? Temperature. Here it says the concentration of iodine in the equilibrium can be increased by what? Rising the temperature. Rising the temperature favors the what? Endothermic reaction, which is the forward reaction. That is the correct answer. What about adding a catalyst? Adding a catalyst will only fasten the rate, make the rate of the reaction to do what? To get shorter. So it's going to react fast to produce what? This product. So it's not shown there. Lowering the pressure. I have told you that lowering the pressure, both increasing the pressure, does not have effect here because the volume here are the same thing. Now the final question, and I have my last tip here. So we have that in the diagram above, the respective activation energy for the catalyzed and uncatalyzed reaction in kilojoule are A 50 and 45, B 45 and 50, C 40 and 45, D 25 and 35. So what do we mean by catalyzed and uncatalyzed reaction? If you look at this reaction, this means that the reactant here are A plus B. These two gave us what? C plus B after reaction. And because they are in equilibrium, this could also give us back what this is over here. Now look at what I mean. Catalyzed or uncatalyzed reaction. For this reaction to give us this reaction, look at they follow in this part. They are reacting. From there, they started reacting. They started reacting. In this top plate, they start forming a product, forming the product of C and B until they now finally form the constant what? Product. This is a what? Uncatalyzed reaction. We don't put catalyst. Now, when you put a catalyst is going to increase the rate of reaction, or it will decrease the rate of it, makes that reaction to happen faster. So look at where we now put catalyst. Catalyst is now going to make this reaction that takes all of this way to just take a small part and then form the same product. That's what catalyst does. Now we are looking for the what? Activation energy. What energy did catalyst activated or with catalyst that made it to form this product in a shorter time, and what energy does the uncatalyzed reaction possesses that made it to form a very late reaction? All right, so what are we going to do? If you look from here you take it back to where the potential energy that its maximum is, which is what? 40. You put it 40. That is what? 40 kilojoule, and at a what? Reactant. reactant. Now you also minus it with the product. From here, you take it back to this what? Potential energy. Now what I'm seeing here is the in between 10 and 20, which is what? 15. If you minus it, you're going to get 40 minus from 15. 10 remove there, 30 is going to give us 25. And this is in kilojoule. So 25 is for what? Activation energy of what? Catalyzed reaction, this pathway. Now, what of the uncatalyzed reaction is this what? Pathway. So we take it back to what? This potential energy line, and then it is what? 50 at maximum. That is at reactant. Reactant. Now you minus it at what? Product, which is when it forms product. You still take it back, you're still going to have what? 15. Now you minus 15 from it, it's going to give us 35. So for that of catalyst is 25, and for that of non-catalyzed is 35. If you look at the option, you find it as option number D. Very simple question. Now, the question that might seems to be difficult for you guys is when they say that, okay, what is the addition of something going to be? I don't have much time. I could have made a video, but I'm going to do that on my next video. So key in the expression best, so I'm going to notify. So once you add a substance to a reactant, for example, this reactant, what is going to happen? I made explanation of that, but I didn't give a question to test you guys. So in our next video, we're going to talk about that. But now I'm going to ending with these special tips that you need to know. Now, in this equation, here, we have two AB2 in gram plus B2 in a gas. This here has to give us 2AB3, also a gas. And then energy here is equals to minus 198 kilojoule. Now this is an equation. In this equation, what we are trying to do here is to consider the. Now if they ask you to find the equilibrium constant in this expression here, what does it mean? Equilibrium constant, put it here, P equals to, it is equals to the product over the product of the product in a reaction over the product of the reactant parts. What does that mean? Concentration of the product is, this bracket means concentration of this product, which is what? A, B, you put this 3 over here. It is all over the product of the what? Reactant. That is this react A, B, that is concentration is this bracket. Also concentration, this other one is B2. This one is AB2. So that is what, if you use this, you divide it by the reactant. So make sure you put it in a bracket. This bracket means what? Concentration. Now, it is not all done here. Now, this 2 here means 2 volume of AB. That 2 volume, these 2 here, you're going to put it as a power of this concentration. So whatever the concentration of this is, if you get that concentration, you raise it to the power of 2. And you divide it to this other one. Now for this AB2 here, it has 2 volume. You put it as what? Concentration, as a power of the concentration. This other one has invisible power, 1 at the side. So all this raised to power 1 is just empty, so we don't add it here. Now this is our what? Equilibrium constant. It is the same in anything you want to do. Equilibrium constant. This is how it is. So any reaction you are asked to find the equilibrium constant, and in the bracket they give you option that contains this and some other wrong answer, you have to check it. What you need to check is very important, this volume over here. All right, so that's the end of today's class. I hope you enjoyed this. Please do one thing for me. As you have learned, share this video in your WhatsApp so that others are going to learn. Share it to friends, invite more friends for me. And if you're not subscribed, click notification because I'm going to make more videos about more subjects and topics, tutorials. And again, if you're not on my online class, WhatsApp me on 08153957022. I'm going to add you. Or if you're in another country, WhatsApp me on +2348153957022. Bye bye.